We have another example of trying to work out the x-intercepts of a cubic graph. And so what we do for starters is we're trying to sub in numbers into x so that the function will end up equaling 0, because that will then help us to get what the factor is. But we don't just dive in and sub in 1 and -1, 2, -2, 3, -3. We look at the first term and the last term to get an idea of what the factors could be. And so I'm not going to run through all of them, but just an example with 45. It wouldn't really be helpful to try test 2 or 8 or something like that, but it may be helpful to test numbers like 5 or 3. And so what I'm going to do is start by trying to sub in 1 and see what that gives us. So that will give us ultimately -1 plus 1. 21 minus 45 is -24. So that didn't work out. And so I'm going to jump to 3. So if I put 3 in for x, I end up with -27 plus 9 plus 63 minus 45. And that gives us 72 minus 72 is 0. So if 3 is an x-intercept, if that got us to 0, then the factor, the bracket that gave us that, was x minus 3. And then what we do to get the other bracket is we say first times first should get me back to the first. So it must be minus x squared. Last times the last must get me back to the last. So that's positive 15. I always put kx in the middle as a placeholder, and then I like to times out and focus on the x squared terms. I call it the double smiley method. So x times kx is kx squared. Minus 3 times minus x squared is positive 3x squared, and that should all equal to our goal of just having an x squared. Some teachers will focus at this stage on the x terms, so they'll times out slightly differently. To me, that's absolutely fine. You can choose what you're going to focus on. Another subtle trick is sometimes you look at the original cubic and there isn't an x squared term, and so you can feel a little bit panicked. How do I do it now? Then if you really want, you could just put a 0x squared, or you could put a 0 here and solve it the same way I'm going to do now. So don't panic if that happens. I'm going to take the 3 across, so that will be minus 2x squared. So then if I divide both sides by x squared, I'm left with k is minus 2. And so when I come back to my brackets again, there's x minus 3 minus x squared minus 2x plus 15. I can factorize that, but life is just so much easier if what's in front of the x squared is positive. So I take it out, but instead of writing it in between the two brackets, and it could lead me to more problems, I can just write it in the front. So I'm taking out a negative from all these terms. Keep that in mind. And when I factorize this, it will just be factorizing like a normal trinomial. And so there are my factors. And so I end up getting my x-intercepts are positive 3 or negative 5 or positive 3 again. And that just means that it will double up, and you'll have a turning point on the x-axis. So let me just show you that for a sec. So the original graph, the cubic graph, had a negative. That means that it's sad. It means it's going downhill first. And the turning points were at -5 and at 3. And 3 was the x-intercept that doubled up. And so what the graph would look like is something like this. It's going down, up, and it's turning right there at 3. So that's how you factorize a cubic graph. I hope that was helpful. If it was, share it with your friends, like this video, and subscribe to our channel.